the thing is, wrong way's okay sometimes. We'll come back to that. Give me a second or two. Give me a second or two. Wrong way gets the job done in a pinch sometimes. Depends on what you're sometiming. So, number 2. Answer that question, Brittany. Go ahead.
It would make the difference because of the bigger the numbers, the less the variable.
Hold that. Oh, sister, thank you. Hold that thought, please. You nailed it on the head. The question is, what is big? And let's come back to that. We'll come back to that. As a matter of fact, I have a big Excel thing for you guys. I think on your first exam I'm putting together that actually talks about how big is big enough to hold the wrong, getting ahead of ourselves a little bit. We'll get to that. We'll get to that. So to do it the right way, we actually have to use the definition of grade, which is rise over run. So we've got to use grade, which is rise over the actual run. See, I didn't use squiggly equals there. I used equals. Because that's what grade is. Now there's going to be some squiggly equals happening here momentarily. There has to be. Because we're about to do some math. Well, first of all, we took measurements. We're not perfect. We actually voted ourselves the worst road crew in the history of road crews. Because we kept screwing things up. I kept screwing things up. You guys kept listening to me. I apologize. But even if we measured things 100% correctly, as soon as you start calculating on those measurements, you introduce error. For example, you measure something on a piece of wood, you make a cut. Well, that saw cuts a 1/16 of an inch kerf out of the wood, which might make the difference between a door not opening and opening if that 1/16 is not there. So there's all kinds of errors that propagate when you take measurements. But at this point, this is the definition of grade. That's what grade is. Yes? Fair with that? Good. So we know what the rise is. That's 23 inches. We measured that. 23 inches. 23 inches. What's the run? Can you figure it out? Yes. And the answer is yes! Because you guys learned a tool at some point in your lives. You guys learned a tool that relates the 3 sides of a right triangle together. Do you remember what it is? Why is it called the Pythagorean theorem? Because the Chinese had it 1,000 years at least before Pythagoras did. That sneaky SOB stole it from him, got his name attached to it. I don't know why the hell Pythagoras got 2,000 years maybe before Pythagoras. Anyway. Well, maybe. So I think it was because there was no internet back then and people discover stuff independently like, aha! And then you find out somebody else had it first a couple thousand years beforehand. Anyway, that's not what I came here to tell you today. What I came here to talk about, the whole reason I'm bringing this up, is that's how you get your rise. Unless you use trigonometry. You guys were mentioning using the hypotenuse and the angle. Unfortunately, that's not part of this course. More than the tangent. The tangent's about as far as I can push. We'd have to use something called the sine, which we'll come back to as well. Yeah, it's good stuff. So let's develop an idea over here, and then apply it over there. So the idea is, whenever you have a right triangle, and I used this twice making that door at that Chicken Creek yesterday. Once for the door itself and once for the swing. Very, very cool. It's very, very cool. Builders use it to make sure that rooms are square and walls are square. There's a beautiful relationship. So let's go ahead and name the parts of the triangle. Hypotenuse. Let's call it leg 1 and leg 2. I think they're called legs if I remember correctly. Doesn't matter what you call them, I'm just going to give names. I think the 2 pieces of a right triangle are called legs, and then the hypotenuse is the hypotenuse. Here's what you have to remember. What's the relationship between the 3 sides of the right triangle? In terms of the variables that I've listed about here. Nice and left. No, Brittany, raise your hand and pull her right back down again.
I can't remember what it's supposed to add up to, but I know that they all...
Something adds up to something.
Yeah.
So we got to add, and it adds up to something. Good. That's a good start. Tell me again, sir. Will, go.
So leg 1 squared plus leg 2 squared equals hypotenuse squared.
That's it. That's it. Probably the most important thing you learn in geometry class, honestly. Besides similar triangles. That's probably the most important thing, but we'll come back to that either today or beginning on Wednesday. The square, thank you, Will. The square of the length of the first leg plus the square of the length of the second leg is equal to the square of the length of the hypotenuse. This is only true for right triangles. It's not true for any other kind. It's totally freaking rad. It's totally freaking rad. It comes in super handy. Now, it doesn't always come in handy in that form, though. Sometimes you need a different form, like we do over there. So if we take this actual equation and apply it to our picture to figure out what that, you can see, we see we're missing a leg. We're missing leg 2 on how I've named it. We're missing leg 2. So let's swing this over there and take a look at how it applies to our image. Let's see how it applies to our image, yes? Okay, good. So our hypotenuse, I think we're going to get rid of these because we're not even using these anymore. We're doing everything in terms of inches, which I think is smart. Can you give me the equation that is at work in our picture? And let's go ahead and give this a name. Since we're solving for it, we're going to call it x. You guys are used to that, right? Solving for x. Let's just call this x. Can you give me an equation that ties it all together? If the hypotenuse is 304 inches, and the rise is 23 inches, can you give me, you don't have to solve it yet, just give me the equation in that Pythagorean form. Tell me, help me out.
23 squared plus x squared equals 304 squared.
23 inches squared plus whatever we're looking for squared equals 304, put that in the wrong place, inches squared. Stop right there. Make sure we're happy with that. Getting the equation is one thing, solving it is something different. I want to make sure this is one of those things that all math students, I shouldn't say that, many math students have a problem getting from that and then solving for x. There's a very, very important thing that sometimes people forget to do, and that's why I want to do it here and a couple more times before we're out of here. Brittany, go.
Square the numbers first, and then
Good.
you will minus
Excellent.
23 squared
Yes.
over to the other side to get the x.
Now, would you like to explain? What Brittany just said is, using our little equation here, our little template, we have the equation 23 inches squared plus x squared equals 304 inches squared. What many, many math students will do is try to get rid of the squared right away. Try to get rid of the squared right away. They'll dot the squares down and say that's the same thing as 23 plus x equals 304. Now, that can't be true. That can't be true. Because how many of you guys have heard the shortest distance between 2 points is a straight line? How many have heard that phrase before? Almost everybody in the room has heard that phrase before. Well, if you solve this equation by knocking the squares off, that means you're admitting that the distance between that point and that point is the same as the distance from going from here to here and there to there. Now you know that can't be true. This has to be longer than this because the shortest distance between 2 points is a straight line. But students will just knock the squares right off and say, it's good, we're done. But you can't do that. You have to use order of operations on that expression. And that says do the exponents first and get rid of them. Get rid of the exponents. 23 inches squared is what?
529.
529. Let's just give you a quick preview of your next project. 529 what?
Inches.
529 what?
Inches squared.
Ah! 529 square inches. We squared the inches, yes? It's inches times inches. 529 square inches. Many of you are not going to care. You're going to be like, it's 529. I'm going to put inches squared on there because it's important to know the difference between an inch and a square inch. What you just did was you took 23 and multiplied it by 23, thus creating 2 dimensions, which is squared inches. Think about it that way. Please, Taryn, right?
Yeah.
Go ahead.
Subtract the 23 from 304 and then square it.
Hold that thought, if you would. Let's come back, if you don't mind, let's come back to that. Because we're smack down in the middle of this solution now, if you don't mind. It's not to dismount it, to discount it, but I want to make sure that we answer it in turn. How about 304 inches squared? 90,000 something?
2,460.
Say that again. 92,000, there we go. 92,460? 16. What? Square inches. I'll write it the same way. Inches squared. Yes, very important. Inches squared. Inches squared. So now, you've got this x squared is the only variable you have to deal with. And you've got to deal with this 92,416 square inches and this 529 square inches over here. Can we now solve? This is a quadratic equation. I know it's a bastard move. But can we deal with it? God bless us, yes. Take this guy away from that guy. Solve it linearly. You're solving it linearly at this point. You've got a linear, it's a quadratic unit. But it's a number, 529. Take it away from this and you end up with x squared equals, what do you get, friends? 91,000 and what?
887.
887? Did I hear that right?
Yes.
Good. See, now we can knock down the stuff in the correct order. It goes back to Lego. And this answers Taryn's question. It goes back to the Lego approach. When you were building this side of the expression, the first thing that happened to x was it got squared. Then we added on this number. So we had to subtract that first before undoing the square to keep with our Lego methodology. That's why I taught you the Legos. Every equation can be solved using Legos. But you got to make sure you obey. If you put a gear down and then an axle and then another piece on top, you have to pull that top piece off before you get to the gear. Otherwise, you're going to break Legos. And Max doesn't like when that happens. All right? You ready? What is x if we take the square root of this, 91,887 square inches?
303.13.
We end up with x is about equal to, give me that,
303.13.
we're going to call that 303 inches. Because we probably shouldn't use any more decimals than that, only because we didn't use any more decimals than that in our measurements. We measured off to the nearest inch, yes? We shouldn't even put the 0.1, should we? Honestly. We shouldn't, because, and this is something you don't have to memorize, but it's the idea of significant figures. Since we only measure to the nearest inch, we probably shouldn't allow ourselves anything more than inches in our calculations. I mean, you're looking at your machines and it's giving you 10 decimals, isn't it? But you're not entitled to all those. You're not entitled to that much precision. The only way you'd be entitled to that much precision is if our original measurements had that much precision. Kelly, what's on your mind? Tell me what's on your mind.
Well, using significant figures, you've got 5 significant figures out there, so once you use 5...
Careful. In our original measurements, how much did we have? 303, 304, and 23.
Right.
Technically speaking, we've only got 2 at best, right? 23 inches. So honestly, if I was being true to sig figs, I'd have to call this 300, I think, and not even 303. I think. I could be wrong about that. Am I wrong about that? Don't worry about it. Go to the nearest inch because we didn't have any better than that in the beginning. I forget my rules for sig figs because I've been in chemistry in 20 years. But basically, I'll tell you what to round to in general when you're doing these calculations. But just realize that your calculator, although it gives you 10 decimal places of accuracy, doesn't mean you're entitled to all that. If you're being kind of literal as far as what you're entitled to do for measurements. Is that fair? I saw their hand go up. I thought maybe.
I was just saying,
Oh.
so if they had given you a point in that, then you...
Sure, I'd feel better about using that 0.1 if I had 304 point blah blah blah. You can get more precision if you need it. There's digital micrometers, there's digital meters that will actually give you more precision than we used. I just don't have one. I have a tape measure and my crack team of measurers. Cool? Good, like the A-team, but for measurement. All right, now, did you catch? I know it's easy to get lost in the calculations, but go back to our image. Do you see how interesting this is?